Hi everyone, I Dr. Suman, Assistant Professor from the School of Basic and Applied Sciences, Maharaja Agrawal Universities. My today's topics is of operation research is on the classification of models in operation research. So let us see some classification of operation research. These are the basis of on the basis of the classifications. These models are classified on the basis of structure, purpose, time, behavior, degree of certainty, and solution procedure. So on the basis of structure, these models further divided into two types: physical and symbolic model. And again, physical model is further divided into two categories: iconic model and analog model. And the symbolic model again further divided into two models, that is a verbal model and mathematical model. And on the basis of the purpose, the models are divided into three types, that is a descriptive, normative, and predictive model. On the basis of a time and behavior, models are two types, that is a static model and dynamic model. On the basis of the degree of certainty, we have again two types of a model, deterministic and probabilistic model. And on the solution procedure, we have again two types of a model, analytical and simulations model. So let us discuss all these models one by one. So firstly, we have a classification based on the structure. So on the basis of the structure, we have a physical model and iconic model. So firstly, let us discuss the physical model. So we can say that these models provide the physical appearance of the real object under study, either reduced in size or scaled up. So these model cannot be So these models cannot be, we can say that these models provide a physical appearance of the real object under study, either the reduced in size or scaled up. So these model cannot be manipulated and are not very useful for the predictions. Therefore, problems such as a portfolio section, media selection, production scheduling, etc., cannot be analyzed with the physical models. So again, these are further divided into two categories: iconic model and analog model. So what is the iconic model? This model retain some of the physical properties and characteristics of the system they represent. Okay, and the iconic models is either is an idealized form or a scaled version of the system. So it is said to be a scale down when the dimension of the model are smaller than those of the real object, and the model said to be scaled up when it is bigger than the real object. Okay, so we can take some examples, that is a globe representing the earth, blueprint of a home, model of a cell in a biology. Another example, we can take baby toy and a car as a model of an automobile. Okay, these are the examples of the iconic model. Next, we have a analog model. So these model represent a system object by using a set properties different from the ones held by the original object or a system. So there is a no look alike relationship between the models and the original. So this model represent a system by the set of the properties different from that of the original system and does not resemble physically. Then after the problem is solved, the solution is reinterpreted and in terms of the original system. Next, we take some examples, that is the organizational chart represents the state of formal relationship existing between the members of the organization. Another example, maps in a different color may represent water, desert, mountains, etc. So these are the examples. Another example, we can take graphs of a time series, stock market, etc. may be used to represent the quantitative relationship between any two properties. Okay. Next, we have a symbolic model. So these models use symbols, by its name, symbols like letters, numbers, okay, to represent the properties of the system. So these models are used to represent relationship which can be represented in a physical form. Symbolic models again further divided into two types, that is the verbal model and mathematical models. And we can say that a verbal model describes a situation in a written or a spoken language. For example, written sentences, books, newspapers, journals, etc. etc. And the mathematical models, this model represents the characteristics of a situation or a reality by using a set of a mathematical symbol and relationships. So these models are widely used in operational research due to their capacity to depict the complex relationship among the variable of a problem. For examples, the symbol in addition, subtraction, multiplication, and division. So next type we have based on the purpose. Okay, so again further we have three types based on the purpose, that is a descriptive model, predictive model, and normative models. Okay, so a descriptive model is simply describes some features of a situation based on the observation survey or other available data of a situations and do not predict or recommend. For example, result of an opinion poll. Okay, block diagram representing an algorithm or methods for solving a problem. Okay, next we have a predictive model. So these models indicate, we can say that if this occurs, then that will follow. Okay, they relate dependent and independent variable and permit trying out. What if questions? In other words, these models are used to predict the outcomes due to a given set of alternatives for a problem. Examples we can take: television network trying to predict the election result before the counting of the votes. And another example we can take rain forecast before the actual rainfall. Okay. Next we have a normative model. So when a model has been repeatedly successful, it can be used to develop objective decision rules or criteria for optimal solutions. Okay. So these models are applicable to repeated problems. Okay. For example, linear programming is a normative or a predictive model because it prescribes what the manager should do. Okay, so classification, next we have based on the time reference and behavior features. So again, the first type is a static models. These models are considered independent of time. They do not take into account the effect of changes taking place during a particular time period. Okay, it involves only one decision for duration for given time period. Example, we can take an inventory model. Can be developed and solved to determine economic order quantity for the next period, assuming that the demand is planning period would remain the same as that for of today. Okay. Next, we have a dynamic model. Based on the time and behavior, these models consider time as one of the important variable and taken into account the effect of changes, we can say that, generated by time. So this involve not only one, but series of interdependent decisions are required. Examples we can take: dynamic programming, in which all possible results are analyzed and best solution is selected. Next, we have a classification based on a degree of certainty. Okay, so again, the first model based on the degree of certainty is deterministic model. These models makes assumption of certainty and perfect knowledge. Okay, in these models are the parameters are completely defined. For example, then linear programming problems, assignment problems, transportation problems. Okay, in all these types of models, the parameters and assumptions are completely defined here. Then next we have a probabilistic model. The model in which at least one parameter or decision variable is a random variable are called the probabilistic model, we can say that. Okay, variables are independent, which is a function of dependent variables. This means the payoff due to certain changes in the independent variable cannot be predicted with the certainty. However, it is possible to predict a pattern of values of both the variables, so by their probability distribution. Examples we can take: probabilistic inventory models are used under the conditions of certain demand to decide the economic ordering quantity. Okay, game theory, we can take an example where saddle points or equilibrium points of the players does not exist. So we apply the probabilistic model here. Next, we have a classification based on the solution procedure. So first model is analytical model. These models have a specific mathematical structure and problems can be solved by the running specific solution procedure. Okay, any optimization model which require maximization or minimization of an objective function is an analytical model. Examples, we can take a general linear programming problem or special structure transportation and assignment problem. Okay, next we have a simulation model. So these models also have a mathematical structure but are not solved by the applying mathematical techniques to get a solution. So instead of a simulation model is essentially a computer-assisted experimentation on a mathematical structure of a real-life problem in order to describe and evaluate its behavior under certain assumptions over a period of time. So these are the classification based on the solution procedure. So these are the different types of the models we have on the basis of the structure, purpose, degree of certainty, time behavior, and solution procedures. Okay, and we can use this model, use these applications of this model according to our need and according to our problems. So that's it about the classifications of models in operation research. Thank you.